Welcome to Chapter 2 on Kinematics. For this part 2 here, we are going to learn projectile motion. Okay, what is projectile motion? We have another name for projectile motion called the parabolic motion. Okay, let's look at one of the example here. What is parabolic motion? Okay, these few angry birds here, they are very angry. They play, they're shooting this angry bird here from this end to this end. Okay, now this motion, we call it parabolic motion. Okay, we are going to find, oh, what is the speed here? Let's say I shoot it up with 10 meter per second at 30 degree from the horizontal. Okay, at 30 degree from the horizontal. Let's say this is a 30 degree from the horizontal. Let's shoot it up with 10 meter per second. Will I be able to hit this target? In this case, obviously, they miss a target. So what is the horizontal distance? We call it the range that we need to shoot such that you will hit this place. What is the time for it to reach the highest point? What is the maximum vertical height from the initial launch? All this we need to answer in projectile motion. Okay, let's go and analyze how do we find all these variables. Now let's define what is the meaning of projectile motion. Projectile motion is a two-dimensional motion. In the previous lesson, what you have learned was one-dimensional, means one straight line motion. For example, this thing just fall down vertically or just go up vertically, right? This is what we call one-dimension motion. Now we're doing two-dimensional motion, in which one direction is uniformly accelerated, while its perpendicular direction is moving at constant speed. What does that mean? For example, I have a ball here. I throw with this initial velocity v, where it will go if there's no vertical acceleration. After 1 second, they might reach here. Okay, just imagine there's no gravity. Okay, you just throw a ball horizontally. After 1 second, they will reach here, right? After another second, they may reach here. After another second, they may reach here. Okay, you see the distance from here to here is the same as distance from here to here. It's the same as distance from here to here every second. Okay, because they are non-accelerated. What if we on the gravity? We have gravity here. Gravity here now. This ball acted by gravity at the same time. So there's a vertical component of velocity that will be affected, right? So horizontally, there's no accelerations. The horizontal component of the velocity, we call it Vx. They are not affected by acceleration. Vertically, the vertical component will be affected by the acceleration. So the vertical component, the distance travel will be keep on increasing every second, right? Because the speed is increasing every second. It increases by 9.81 meter per second in every second. Okay, wow, the distance keeps on rising. This is from here to here is 1 second. From here to here is another second. From here to here is another second. Can you feel that? So after 1 second, what is the horizontal distance travel here? After 1 second, what is the vertical distance travel here? So after 1 second, what is the resultant distance travel? It should be here. Okay. Now what about here? Another second they reach here. Another second they reach here. So the resultant is here, right? For this one, the resultant is here. We see this is what we call the parabolic motion. Is a curve. Now let me show you this better picture here. Now it's the same. So you see horizontally they travel at constant speed. Every second they travel the same distance, okay? But vertically they travel with increasing distance because they travel with increasing speed, right? So with the resultant is here, initially here. So horizontally is this position, horizontally this position. So this is a resultant position initially. Okay, let me use another color. It is a resultant position initially. After 1 second, this traveled for this distance. So the resultant vertical is this position. The horizontal distance travel is this. So the resultant is here. Okay, and you trace for the same path. This and this, this and this, this and this. Okay, finally, you can trace a parabolic path. Okay, with uniform one direction accelerated, another perpendicular direction, horizontal direction in this case, constant speed. Okay, must it always like that? Must it always vertical accelerated direction, the horizontal constant velocity? It's not like that. Okay, let me give you another example. Let's say I have a vertical plate here, positive plate, negative plate is under electricity. You will learn this in the JC2. Now if you have an electron, okay, let's say an electron. Okay, electron is very light, so the gravitational force acting on the electron, we can neglect it. So under this situation, the electron will experience a force to the left, right? Because the electron definitely is a negative charge, will be attracted by the positive plate, right? What if we launch the electron in a vertical manner, but experience an acceleration in this direction, how it will look like. Okay, so you should be able to predict that every second the position will be constant distance, right? Constant distance every second. But horizontally, the distance travel will be increasing every second. Wow, increasing. Okay, so after 1 second, so this is the resultant position. This is the resultant position. This is the resultant position, right? So you see, you get a curve like that. You get a curve instead of a straight line. Okay, please, this is a curve, not a straight line. Okay, I never draw accordingly to the scale, but this is a curve because the horizontal distance is greater. So in this case, you see, the horizontal direction is accelerated. The vertical direction is constant speed. Okay, so please do not have a misconception. Do not think that only the vertical direction is accelerated, whereas horizontal is constant speed. They can be either way. Okay, depends on the situation. Let's learn some of the usual terms that you will use in projectile motion. First is trajectory. What is a trajectory? This is the trajectory. Okay, it is the path traveled by the projectile. Okay, here to here, let's say. Now, what is the range? Range referring to horizontal distance travel. This is the range. Okay, what is the angle of projection? Angle of projection referring to what is the angle? Okay, let's say I launch at this velocity. This is what we call the angle. Oh, this is the at angle 30 degree from the horizontal. Sometimes they give you, oh, let's say this is 60. Oh, this angle of projection is 60 degree from the vertical. Okay, this is what we call angle of projection. What is time of flight? Depends on the situation. If it asks you, what is the time of flight from here to the maximum height? So where's the maximum height? This is the maximum height, right? So from here to here is the time. So from here to here is the same time, right? Because there's symmetry from here to here. Take time t, from here to here also take time t, okay? In other words, as long as they are the same horizontal position, okay? Let's say from here to here, the time will be equivalent to the time from here to here. From here to here, equivalent to the time from here to here. They are symmetry, okay?